because already only theoretical things, no? So this is incident light. This is a photodiode. Now, if I increase the intensity of light, how the response for collector versus the output characteristics curve. I'm going to increase the intensity of light. So this is IC in milliampere. This is VC. So here IC is this one. So the if intensity of incident light if intensity of incident light increases, what will happen to the characteristics curve? Say one thing, as the intensity of incident light increases, tell me what will happen to the photo current? Is it diode reverse biased? First of all, photodiode, is it reverse biased? Yes, it is reverse biased. No? Go back to photodiode. What are the photodiode? Is that okay? So the curves were of something like this, no? So as we will increase the reverse bias, the reverse, as we increase the intensity of light incident on the photodiode increases. So this particular thing, what when the reverse current will increase, the photo current will increase. I think the curves were like this. If you hope. Okay, I'll make changes. Huh? Is that okay? And this is the reverse voltage. This is a current, reverse current. Am I right? And these are intensities. So I'll write it intensity I01, I02, I03. As you increase the intensity of light, so the photo current will increase here. And what is this photo current? Photo current is nothing but the base current, no? Here, the current which is flowing. So as the intensity of incident light increases, the base current here will increase. If base current increases, we know the curve should be. So the response curve. Uh, IB1, IB2, this is IB3. And what is IB1? IB1 is this particular thing, base current. So now I'll write the reason as intensity of light incident on photodiode increases, the base current IB increases. As base current IB increases, so this should be the suitable curve. So I'll better write this as intensity of light. I01. What are I01? So here I03 greater than I02 greater than I01. Okay, are you getting? So there are several ways are there for testing things. Huh? So many things are there. It should be reverse bias photodiode. No, the same photodiode, if I connect P to here, if I reverse the polarity, then if I increase the intensity of light, then in that case, what will happen? The curve will be horizontal. The reason for that, when the photodiode is forward biased, the majority carriers, the number is so high that as you increase the intensity of light, the increase in minority carriers will be very less. The increase in photocurrent will be very less. The fractional change in photocurrent will be very small, very negligible compared to fractional change in majority carrier current. And what will be the intensity of, what will be the response? The response curve will be like this only. Able to understand? So I'll put one more, the same photodiode. Let me forward bias here. Same circuit, no? Yeah. Yeah, we'll take it. Incident light, photodiode. So what is the state of photodiode? It is forward biased. Earlier it was reverse biased. I'm writing RB. I think it is sufficient. No. What will happen to the this IC versus VC graph? As you increase the intensity of light, the response of the curve will not change. Any reason for that? The photodiode is forward biased. So though intensity of light increases for same thing, all the I naught one, though intensity of incident light varying, but the current what happen will remain same. I naught one are, are intensity of incident light. Okay. Just some several ideas I'm sharing it, that these are just some all possibilities. Any doubt if you have, you can clarify.
Sir,
Ah,
can you explain how to check whether it is in saturation or active region, sir? Transistor.
transistor only collector base. If so like a VCC for a you get this VC will be there. Suppose a VCC is 10 volt. So what is the best thing is like you can plot this curve. This is VCE. What is the formula? VC equal to VCC minus ICRC. This is something not above circuit. If I plot this curve, VC versus IC, I'll get a curve with a negative slope. So what is the region? This region is what? Active region. This is active region. What about the cutoff? Cutoff, this is a cutoff region. And this is the saturation region. not exactly well defined. Okay, just some roughly. So what is the best practice? We know applied voltage VCC 10 volt. If I get VC say some 0 2 volt or 1 volt, definitely it is in cutoff. Definitely
Sir,
it
you
is in
mean take
saturation.
it as
Saturation. If VC is equal to almost equal to 10 volt or 9 volt, 8 volt, it is in cutoff. If VC say some around 5 volt, then it will be in active region. Okay, yeah.
okay, sir. Understood.
That's the simplest method. We'll determine this, the value of RC, RB, and RE. Here the circuit is this one. I think I should help you with the circuit. So for which circuit you have plotted this.
Sir, once when you open page number 3, sir.
For this collector base